last lecture, I have put out the assignment for Engineering Maths 4, so can you please have that in for next Thursday at midnight? The reason is there's a meeting between Strathclyde Uni and the college, and I need to have the results in for the following week. So I need the weekend to mark them, and I need the Friday to mark them. If you get any issues with that, please let me know. Right? Now, there's a new app that you can use called Office Lens. It's a Microsoft app, and effectively what that will do is it will just, using your phone, it becomes a scanner, and it will condense all your photos into one PDF file, which will make it easier for you to send, and it'll make it easier for me to mark. So I'll put a link up to that app. I would say you'll probably use it quite a lot at uni and stuff over the course of the next year, and it's also really good if you do anything by hand, just so you can email it to yourself or whatever. So let's have a look at the last thing. So the first thing I'm going to do is I'm just going to do a little bit of revision for us, okay? So revision. And I just want to revise what we did in the last lecture, which is separation of variables. So I'm just going to say, find the particular solution using separation of variables. Now, it's a particular solution, so I need the differential equation, which I'm going to put here. dy by dx equals y plus 4 over x plus 8. And, of course, I need my initial conditions, which is when x equals 1, y equals 4. Okay, remember that could be written as y of 1 equals 4. They mean the same thing, right? So both of those can condense into that there. That means when x equals 1, y equals 4. So you just watch that. It might be written like that in an assignment or an assessment or when you get to university, right? So separation of variables. Now my dy is on the top, my dx is on the bottom. So that means I want all my y's on this side and all my x's on this side. Right, so that seems fairly easy. I'm just going to move that y plus 4 over to here. So that means it's a divide. So you've got 1 over y plus 4 dy equals, so that x plus 8, well that's staying there because it's got an x in it, and it's on the bottom, so I need to put a 1 on the top of that as well. dx. Right, and that's me separating my variables, so that's exactly what I wanted to do. So now I've just got a standard integration question, so I'm just going to integrate both sides. That side with respect to y, that side with respect to x. So this is dead easy. It just becomes ln y plus 4. And this here just becomes ln x plus 8. And the magic thing is plus c. Now, as I said to you before, as soon as there's an ln in this side, we change that constant so it becomes an ln as well. Now remember, the constant's just a number, so it doesn't matter what you do to it, right? So I'm going to make that constant, instead of calling it c, I'm going to make it lnd, right? Okay, you don't need to write that wee comment at the side, but I just do it to show you what I've done. Right, now, what you want to do is combine your ln terms on the right hand side together, because remember, the whole point of this is you want your final answer to your differential equation to look like y equals something. Right, that's the dream. But it doesn't look like that at all right now. So what I need to do is put these two terms together, because I can only get rid of logs if there's one term on each side. I've got two terms here, so I need to put these together. So the first thing I need to check is, are there numbers in front of these ln's? No, there's not. So that means I can just go straight to combining them together. And when you combine two ln's through adding, it becomes a multiply. So that's ln dx plus 8. Right, now I'm ready. I can take the ln's off, because remember, you can just imagine I'm just taking exponential of that side and exponential of that side. So that means that these two cancel off and these two cancel off. So y plus 4 equals dx plus 8. And if you want, you could write that as dx plus 8d if you wanted. It makes no difference to me. And then I want it to be y equals. So it's dx x plus 8 take away 4. And that is your general solution there. But remember, I didn't want the general solution. I wanted the particular solution. So you substitute in your values here. No, I'm not going to write particular solution yet. I'm going to work out what out. So basically what I want to do is work out what that letter D is. So my initial conditions are when x equals 1, y equals 4. Okay, so let's substitute that in. So 4 equals D, 1 plus 8, take away 4. So let's move that across. So 8 equals 9D. So D equals 8 over 9. So that means your particular solution is y equals 8 over 9 D plus 8, take away 4. And if you really want, y equals 8 ninths of D, so multiply it out, plus 64 ninths, take away 4. So 64 over 9, take away 4 is 28 over 9. And that's me done. Oh, so whatever. It should be x. What am I doing? It should be x in the particular solution, not d. What am I doing? It's been a long week, as you can imagine. You're substituting for the letter D, you're not substituting for the letter X. Had a wee moment there. Okay, now if you really wanted to, what you could do is you could see if it actually fits the answer fits the differential equation. So you could differentiate y with respect to x, you could substitute y into here, and you could see if both sides are equal to each other, because then you would know that your solution to your differential equation is correct. But we don't need to do that. I'm happy with just doing that. Right, now this is in the unit spec, so in the actual course, there's a whole section on using transformations to solve differential equations. Now, I will do a lecture on that at some point, but we don't need it for the assignment, right? So you're going to need it for next year if we're going to uni, but I don't need you to do it in the moment. So I would rather focus on the stuff that you need for the assignment than the transformation stuff, right? So this is, I call it the third type of differential equation. The first type is separation of variables. The second type is your transformation. The third type is integrating factor. Right. So integrating factor, right, it's sometimes known as IF. Now, we knew something was a separation of variables because we done x, a function of x, multiplying a function of y, or a function of x dividing a function of y. Right. So the form of these is slightly different. It's when you've got dy by dx, right? Now there can't be anything in front of dy by dx, it has to just be dy by dx, plus your function of x multiplied by y equals another function of x. Right, so this is when there's an add or a subtract involved, right? All the other ones we've seen so far have had just multiplies, or if there's been an add or subtract, it's been in a bracket or on top of a division sign, right? So this is what it would look like. You could have something like this: dy by dx plus 2xy equals e to the power of x. So you can see that your function of x is 2x, and your function of x, its answer is e to the power of x. I mean, it doesn't have to be an add. It could be something like this, but it's still of the same form. Right, that's of the same form, because if you dy by dx plus or minus something to do with y equals a function to do with x, right? So in this case, your function to do with x would be negative 1 over x, and your function of x at the end would be 3x cubed. So you need to be able to pick out what p of x is and what f of x is. So a good way of doing that is just covering up whatever the y is. So if I cover up that y, p of x is 2x. If I cover up that y, that means that p of x is 1 over x, right? So it's a key thing being able to pull that out, right? So here's a method, and it looks like there's many steps, but I'm just writing out step by step to try and make it easy for you, right? This is our method here. 1. We identify what P of X is, right? 2. We integrate P of X with respect to X, okay? Which is obvious, right? Then 3, your integrating factor which for shorthand we call IF, is equal to e to the integral of P of X dx. So effectively all your integrating factor is e to the power of whatever we've worked out in part 2. Right? So that's why we do these 2 steps first, because your integrating factor is e to the power of whatever that is here. Now, make sure you simplify your integrating factor if you can. Right? It makes it a lot easier. Right? Step 4, you multiply both sides of the original of by your integrating factor. 5. Your left hand side and this will always be the case, that's why the integrating factor works, always becomes d by dx of whatever your integrating factor was multiplied by y. That looks like xy. So multiplied by y. Right? And this is because of the product rule. As usual at this point in the course, and because we're doing this distance learning, I don't have enough time to do the proof of why the left hand side becomes this. If you look in the first order differential equation booklet, the proof is in there. Right, so please have a look at that if you want to know why it works. I'm just showing you the process. You integrate both sides and you move stuff about so it becomes y equals something. Right, just like we did with the separation of variables stuff. Right, so 7 steps, but the first 3 steps will be done in about 2 seconds, and the next, I think it will take you about 2 minutes to do each one of these questions. It's not a particularly complicated 7 steps, right? But people do find this difficult, so don't worry if you do. Right, example number 1. Find the general solution. A differential equation will never normally say solve. We should always give you what type of solution it's looking for. So general solution this time. So that means you're going to have constants in your final answer, so you don't get initial conditions. Right. Okay, so I see I've got a dy by dx, but this time I've got an add or subtract. So I know it's an integrating factor question. Right, now the form that we have is dy by dx plus p of xy equals f of x. Right, that's the format for an integrating factor differential equation. Right, the first thing you've got to do is work out what p of x is. So P of x is whatever is happening to y. So see if you just cover up y with your finger, that tells me what P of x is. So P of x is 2. Right? Then you integrate P of x with respect to x. If you integrate 2, you get 2x. Simple as that. Now, your integrating factor is e the integral of P of x dx. But I've already worked that out. That's 2x. So if is e to the power of 2x, and that's you done. Now, sometimes you might get to stage you've got ln's in here and stuff, and you need to simplify because e and ln will cancel each other out. But in this situation, that integrating factor is as simple as it can be. Right, so then what we do is we multiply our whole differential equation, so everything, by e to the power of 2x, right? So that's going to be dy by dx times e to the power of 2x plus 2y times e to the power of 2x equals e to the power of 3x times e to the power of 2x. Right, so that's dy by dx e to the power of 2x. That's not changed. Now there's that, 2y e to the power of 2x. But we know if we multiply two bases that are the same, we add the powers. So that's e to the power of 5x. That's just indices. Remember, x to the power of a plus x to the power of b equals x to the a plus b. Right, that's our rule from indices. This time we've got e here. Right, that's basically the last. Right, now, once you've done that, this side here, the left-hand side, always becomes d by dx of whatever your integrating factor was, which is e to the power of 2x, multiplied by y. And this side stays the same. Right, now it's because of the product rule. If you differentiate this here, you give you a product, right? Because you differentiate that, you would differentiate that, get dy by dx, leave that alone, plus differentiate that, 2e to the power of 2x, and you'd leave y alone, right? Because that's what we would do with implicit differentiation, right? So it's just a product rule with implicit differentiation. You don't need to worry, this bit is always d by dx, so whatever the integrating factor is times y, but that's the reason that it works. So I've just kind of basically given you the proof there. Right, now, what we do when we get to this stage, we integrate both sides. I'll put a dx in there, right? Right, and that's... Then, what it's telling me to do is integrate the derivative. Integrating and differentiating are the opposite of each other, so nothing happens. So I'm just left with e to the power of 2xy equals, and I integrate this, that gives me e to the power of 5x over 5 plus c. Right, now remember what I said, I always want it to look like y equals something. So, I need to divide by e to the power of 2x. So that's e to the power of 5x divided by 5 times e to the power of 2x plus c over e to the power of 2x. Right, so that's me basically finished, but I can simplify those. I'm dividing two bases that are the same, so that means I subtract the powers. So that gives me e to the power of 3x over 5 equals c over e to the power of 2x. Lovely stuff. Okay, next one. Next one's a good example. I'd pay close attention to this. Right, example number 2. Now we're going to have to use rules of logs here a little bit. but don't worry too much about it. Right, so I've got find the general solution. I'm just going to shorten that to GS because my writing's getting worse today. Right, so dy by dx take away y over x equals 4 over x squared. Right, so I know it's an integrating factor question because there's an add or subtract that's not on the top or the bottom of a fraction or that's in a bracket. Right, it's sitting out in the middle of the equation. Right, now, quick thing, this has got to be dy by dx. If this isn't dy by dx, I've got to change it. Right, so if there's an x there, I need to divide everything through by x or something like that. Right, but we'll come to questions like that in a minute. Right, so first thing I do is I've got to pick out what my px is. So px is whatever is happening to y. So if I cover over y with my pen, it tells me that p of x is negative 1 over x. Okay, so you always just cover up the y, and what would be there? Right, now, I need to integrate that. Now remember, to integrate 1 over x is ln. We don't make that negative x to the power of negative 1. That doesn't work. Right, because we'll be dividing by 0. To integrate that, it gives me negative ln x. Okay, looks alright so far. So then, your integrating factor is just e to the power of whatever this thing is here, negative ln x, right? Because that's part 3 of my procedure. Now, here's a little trick with this one. Now, I've got e and I've got ln, and I know that those are the opposite of each other and those are going to cancel out, but I can't cancel them out because of this negative thing, right? So what I've got to do is get that negative away. I want it to look like that. That's the dream. So see that negative, that's really a negative 1. And I know that with ln's, I can move that up and make it the power, because that's one of my rules of logs. So I'm going to move that up to there. So that lets me say that my integrating factor, these two cancel out, is x to the power of negative 1, which is of course 1 over x. So we'll use either one of these depending on how much easier it's going to make our equation look. Right, so there's a wee bit of a tricky thing in there because we had to simplify our integrating factor, and I said that during the procedure. Right, so now we're going to multiply everything here by 1 over x. So dy by dx times 1 over x plus, take away, my mistake, take away y over x times 1 over x equals 4 over x squared times 1 over x. Now, I wouldn't expect you to write that out. I'm just doing it to show you the actual process involved. You can do, might make it easier for you to write. That means you've got, I'll put the 1 over x first this time, I don't know, I just prefer it. 1 over x dy by dx, take away y over x squared equals 4 over x cubed. Right, so that's me finished part 4. Right, now this bit always becomes d by dx of your integrating factor, which is 1 over x multiplied by y, every time. And the right hand side stays the same. Then we integrate both sides. Cool. With respect to x. So things are looking good. Now, this will always happen at this point. These things here are the opposite of each other, so that cancels off. That cancels off. So I'm just left with y over x here, because 1 over x times y is y over x. And here, well, I can't integrate that yet because I've got to rewrite that as 4x to the power of negative 3 dx. And now I'm going to integrate it. Like that. So y equals, I'll keep my y over x, yeah, negative 2 x to the power of negative 2 plus c. Okay, I'm nearly there. I need to make it y equals, in fact, before I do that, I'm going to rewrite this as negative 2 over x squared plus c. I think I prefer that. And now I'm going to take the x over and multiply both things. That's going to be negative 2x over x squared plus cx. Because it's on the bottom here, so it jumps up onto the top because you're multiplying through by it. You can simplify that off. So y equals negative 2 over x plus cx. Right, 3 really good questions that will help you with the one in the assignment are questions 1, 2 and 3 from page 35 of the first order differential equations book that you have. Right, let's do another example. Right, so this time this is example 3. Now there's a couple of wee things to watch here. Okay, and this is again really important for the assignment. Okay, I would say this is the most important one so far. Right, so find the particular solution. So this is not the general solution, this is the particular solution. Should just have written PS for particular solution. Anyway, I've written it now. Of x dy by dx plus 3y equals 4x. And obviously, you need your initial condition. I'm going to give it like that. Right. So, different thing here is particular solution. Key difference. So I've got my initial conditions. Now the initial conditions, I don't like the way that's written. So remember that just means when x equals 2, y equals 1. So that's how I would start my questions, by rewriting my initial condition in a way that I understand better. Right, now, remember my form is dy by dx plus p of x, y equals f of x, right? So what's wrong with my differential equation? I can't have anything in front of dy by dx or anything happening to dy by dx if I'm going to use this integrating factor to do it, right? So that means I need to get rid of this x here. Like, this x is horrible. It's stopping my integrating factor from working. So what I'm going to do is, to get rid of that, I'm going to divide everything by x and divide everything by x. Okay, so that's going to give me dy by dx. If I divide that by x, if I divide that by x, it's going to give me 3y over x. And if I divide that by x, I get 4. Perfect. Now I have a differential equation that I can do integrating factor with. So, first things first, p of x, we lift off our differential equation, so we cover over y. So if I cover over y, I get 3 over x, and it's a plus 3 over x, so it's fine. Okay, then I need to integrate p over x. So if I integrate 1 over x, it would give me ln x. I've got 3 times 1 over x, so that's 3 ln x. So then your integrating factor becomes e to the power of 3 ln x. Cool. I'm nearly there. But remember, just like we did in the last example, I've got E and I've got ln. And I know that those are reciprocal functions, they're inverse functions, so they'll cancel each other off. So I need them to sit right next to each other. So I'm going to use that same rule of logs and take that 3 and move it up to a power on my x. So if is e to the power of ln x cubed. And then that allows me to cancel off my e and my ln. So my integrating factor is just x cubed. So then we multiply both sides of our differential equation by the integrating factor. But I'm not going to use this one because that one was in the wrong format. I need to use the one that was in the correct format for this method. So I'm going to multiply everything by x cubed. So dy by dx times x cubed plus 3y over x cubed equals 4 x cubed. Right? If you want, you can simplify that down, but it doesn't matter because remember, all this side ever becomes is just d by dx of your integrating factor, which is x cubed multiplied by y. And that just stays the way it is at 4x cubed. Right, next bit, we integrate both sides. Like that. So exact same thing for a method as we always do. Right. Next thing. These, same thing as usual, integrating a derivative. It's just the same thing. Right? Cancel each other off. So I'm just left with x cubed y equals, and I integrate that gives me 4x to the power of 4 over 4 plus c. So same thing as always here. Because of the product rule, I can just do that. So that means that x cubed y equals x to the power of 4 plus c. So I'm just going to divide through by x cubed. And then I can simplify that thing there. That just becomes x. That's my general solution. But I wanted a particular solution. Now if I look at my initial conditions were when x equals 2, y equals 1, I think. Let me go and check that. Yep. So we substitute those into our general solution and see what happens. So 1 equals 2 plus c over 2 cubed. Okay. So 1 equals 2 plus c over 8. Right, so I'm going to move that 2 over. So negative 1 equals c over 8, and then multiply that by 8. So that's negative 8 is equal to c. Okay, so my particular solution is my general solution, but with negative 8 chucked in for c. So y equals x take away 8 over x cubed. And that is my particular solution to that differential equation. Now, I'm not going to do it for the simple reason that I've said already, we don't have time. And that is, I'm not going to do integration by parts or integration by substitution involving these questions. It normally is involved in these questions at some point, but I'm not going to do that. Okay? So let's have a look at further example, example 4. So find the particular solution. Right, and I'm looking at dy by dx take away cos y cos x equals 2x e to the power of sine x. That was horrible. And this time y of pi equals 0 is my initial condition. Oh, man. Right, so first thing, I'm going to rewrite this initial condition as when x equals pi, y equals 0. Cool. So I know I've got to use that towards the end. Right, now this isn't the right format because I've got dy by dx on its own. I've got another subtract in here. It's all good. So I know it's an integrating factor question. So first thing I do is I cover over my y, and that tells me what my px is. So px, and watch here, it's not cos x, it's negative cos x. So watch that. So let's integrate that. If you integrate negative cos, you get negative sine. So that means that your integrating factor is e to the power of negative sine x, and that's me. Now, exponentials and sines and cos are completely different things. I can't simplify it, I can't do anything. So that's me as far as I can go. Right, so let's multiply both sides of this equation by e to the power of negative sine x. So dy by dx, e to the power of negative sine x, take away y cos x, e to the power of negative sine x equals 2x e to the power of sine x times e to the power of negative sine x. Cool. So these bits are just going to stay the same. There's nothing I can do with that just now. But I need to sort out the right hand side so because I can simplify that. Right, so I know, same rule as before, I get the same base e and I add those powers together, which should give me e to the power of 0. But what do I know e to the power of 0 is? E to the power of 0 is just 1, so I'm just left with 2x times 1, which is 2x. Right, then the left hand side becomes d by dx of your integrating factor, which is e to the power of negative sine x multiplied by y. So let's integrate both sides. Put my dx in there. Right, so same thing, these cancel off. So e to the power of negative sine x y equals, if you integrate that, that just becomes 2x squared over 2, which is x squared plus c. Nearly there. I just need to divide by that, so that's equals x squared over e to the power of negative sine x plus c over e to the power of negative sine x. And that's my general solution. So it's not actually anywhere near as bad as it looked. Right? When I first saw it, I thought, oh, that's horrible, but it's not too bad. Same steps, we get a fairly straightforward solution. Right, but it's particular solution. So I wanted to know when x equals pi, y equals 0. Right, that's my initial condition. So let's substitute that in. So 0 equals negative x, x squared. So that's pi squared over e to the power of negative sine pi plus c over e to the power of negative sine pi. Now, that gives me pi squared over e to the power of 0 plus c over e to the power of 0, because sine pi is 0, and sine 0, e to the power of 0, remember, is 1, so that's pi squared plus c, so c equals negative pi squared. Not too bad. So then your particular solution is y equals x squared e to the power of negative sine, sorry, I've done it a slightly different way last time, sorry, x squared over e to the power of negative sine x, take away pi squared over e to the power of negative sine x. And that's my particular solution there. So just substitute in the negative pi squared for c. So that should be enough for you to do the assessment questions on differential equations. So there's one of those ones that's like the revision question I did at the start. And then one of them I would say is very like example number 3. Right? So, but have a look through all of this. Try those questions that I've given you from page 35. Please email me if you think you've got any bother doing this, because we do need these results for Strathclyde. Stevie's got the meeting with Strathclyde on the 25th, so please, if you can make sure that this is done, it would be a big help to you and a big help to me. And I also think it's slightly easier than Engineering 3, right? Especially because it's open book, right?